Okay, good morning, welcome to
FamilyMath351a.
FamilyMath351a. So divisibility rules came up this week for both of you. You did it in your math club,
Yep.
right? And then you asked me a question about what divisibility rule.
I think it was 11.
It was 11. So it just made me think it'd be fun to talk about divisibility rules because they're really some really neat math behind it.
Okay.
And it involves something called mods or modular arithmetic. You guys ever heard of that word before?
Yeah. Mm-hmm.
Okay. So what's a divisibility rule that you know?
Well, maybe an easy one like 2 or 3.
2 or 3. Okay, well let's do both. Okay, so 2. What is the rule? Divisibility rule for 2?
Well, if it ends in a multiple of 2.
Okay, so if the number ends in a multiple of
Or
2.
if it's even.
Or if it's even. Yeah.
Well, that's the same thing.
Why is that the same?
Because ending in a multiple of 2 means it's an even number.
Okay. So let's look at the number, I don't know, 358. And can you explain to me why all we have to do is check the last digit to know if it's a multiple of 2?
Well, we can do 2 times 5 is 10, so we can make any number of 10s and 100s with 2s and 5s.
Okay.
So
So in this case, what does that tell me I already know is divisible by 2 for this
Well,
number?
350.
Yeah, 350.
Right, so essentially what we're doing is we're saying this number is 350
Plus 8.
plus 8. And we know that 350 is divisible by 2. Why?
Because,
Because you need a 5 and a 2 to make a 10.
yeah.
It's a multiple of 10, so it must be a multiple of 2. So all we have to do is check the 8.
And that's 2 times 4.
That's 2 times 4. Okay. What about 3? 3 is a little more complicated.
3, you just have to add up all the digits, and if they add up to a multiple of 3, then it's divisible by 3.
Okay, so I'm going to pick a number that I already know is divisible by 3.
Okay.
And I'll do another, how about a 300 one again? How about 369? Oh, actually, you know what? That's a bad example. That's a bad example. How about 420?
20. Well,
So why does summing up the digits work? That's the tricky thing about this rule. Do you know?
you can't make 10s out of the 3s.
Right, you can't make 10s out of the 3s. That's the difference with this rule. You can't make 10s out of the 3s.
Well, you can make like 300. You can make 300s, and you can make 300 since it's 3 times 100.
That's right. You could divide it up and make smaller numbers below,
Yeah.
but that becomes a little bit tricky. It's a little bit tricky, so I'm going to show you what you do here. So what we're going to do is we're going to write this as 4 times 100 plus 2 times 10 plus 0 times 1. Okay?
Yep.
And now we're going to look at the place value numbers when we divide by 3.
Okay.
Okay? What's the remainder when I divide 100 by 3?
Well,
It's 1.
because you have 99.
It's 99. So what's the remainder when I divide 400 by 3?
Well,
Oh,
it would be 4.
which you can subtract 3 from. It's 1.
Okay? Either one is right.
Yeah.
It's either a 4 or a 1.
Well, it would be technically if you write it as a 1. Because you can't divide something by 3 and have a remainder of 4.
Well, actually you can, but normally we don't say that.
Yeah.
Okay, but having a remainder of 4 is actually the same as having a remainder of 1.
Yeah.
Why is that?
Because you
have a 4 is 3 plus 1. So the 3 goes away and then you have 1.
Okay. What's the remainder here when I divide 10 by 1?
if you divide
By 3, sorry, 10 by 3.
1 again.
1 again, and how about now 20 when I multiply by 2?
Well, it's 2.
Or you could think of it as negative 1.
That's right, or you could think of it as negative 1. That's right. There's a lot of different ways to think about remainders, and that's what gives rise to these divisibility rules. What's the remainder when I divide 1 by 3?
Oh,
1.
And how about when I multiply by 0?
There's no remainder now.
There's no remainder.
0 is a multiple of 3.
So when I'm looking to divide by 3 and come up with the divisibility rule, all I'm looking to do, actually, is figure out what the remainder is. And how will I know if it's divisible by 3?
Well, if the remainders add up to be a multiple of 3.
Yeah, which would mean the remainder ends up being 0,
Sure.
right? So, let's see what happens. When I divide 100 by 3,
You get the remainder of
the
1,
remainder is 1. So the remainder here ends up being 4 times 1
which is 4.
plus 2 times
2 times 1.
1 plus 0 times 1. So I have 4 times 1 plus 2 times 1 plus 0 times 1.
So you have 4 plus 2 plus 0. So
And what was special about 4, 2, and 0?
But they were the
Remember.
digits.
They were the digits in the problem.
So if you add them up, you get 6, which is a multiple of 3.
Yeah, so that's where that shortcut comes from.
Hmm.
All right, so
Yeah.
let's talk about a couple other ones, okay?
Alright.